What I'm trying to say is that to check where the ball hits the ground, that's the same thing as saying, where is the height of the ball? When is the height of the ball equal to 0? No, I wouldn't. That's an excellent point. Thank you for clarifying that. Because here I'm going to use h of t, not h prime t, because we want to know about the height, not about the velocity. So I'm looking here at the original h of t, the original, so where is the original h of t equal to 0? And here I have a little bit of interpretation to do. I see that there is this right here, and Desmos will tell me that it's at approximately 3.517. And then I also see that there's another point back here at approximately negative, so h of t equals 0 when t is approximately 3.517 and when t is approximately negative 0.142. And I'm solving that by seeing where does the curve cross the x-axis. Now I want to point something out here that's really important. It has to do with these issues. This is a mathematical answer. If you're a rocket engineer trying to answer this question, do you take these mathematical solutions at face value necessarily? Okay, you say no. Why? What are you going to question about this? Definitely goes in the positive direction. I'm 1000% there with you. Time goes in the positive direction. Otherwise, we're doing some weird time travel stuff that we don't have the budget for. And we fired the cannonball at t equals 0. But there is a notion of negative time. It's just that the notion of negative time refers to what happened before we fired the cannonball. And the rule then was probably different. I agree with you, the initial height is 4, so that means the cannonball was fired from a height of 4 feet. Meters, thank you. That's very important to y'all. And what I want to look at here is, do they keep track of negative time? So if I look at this video, I have the altitude, which is my h of t, and I have the speed, which is my h prime of t, and I have the time, which is my t. Do y'all see why these variables track to what we're discussing right here? We have altitude, which is height. We have speed, which if we're going always in the same direction corresponds to velocity. When it changes and we start coming down, then we'll have to worry about it. But on the upward direction, it's equal to h prime. And we have the time. But you'll notice they do track negative time here. What does negative time correspond to? You see, it says t minus. That's minus 4 seconds. So there's some interesting things here, like even at minus 15. We would have, though, that h of negative 15 in a realistic situation is equal to 0 because we haven't fired it yet. Or in this case, actually, we would have that it's equal to 4. You agree? So our better graph would have like a constant value before negative time. And what you said connects perfectly to this question of, does it make sense to make the domain be the whole thing? Why not? Do we care about where this cannonball is across the entire lifetime of the universe? No, we should restrict the domain to the time that we care about. Now, I cannot tell you what that is. I cannot tell you when to start caring about your cannonball, but you will know when that is when you do this problem. If you actually have a cannonball, you will know when you started caring about it. You probably didn't care about it when it was on the truck on the way to your launch site.